I am Dr. D. Sam Harrison, Professor, Department of Trively, Rohini College of Engineering and Technology. Wave parameters. So, in wave parameters, first of all, we have to see the phase velocity, that is Vp. Actually, phase velocity of a uniform plane wave, it is given as the velocity with which the phase of the wave propagates. It is denoted by Vp, or simply we have to call V. In other words, the phase velocity indicates the propagation of z coordinate in the augment of cosine functions. So therefore, the phase velocity is given by V is equal to Vp equal to dz divided by dt is equal to omega divided by beta. Next, intrinsic impedance. Actually, intrinsic impedance is given as the ratio of transverse electric field to the transverse magnetic field H in an electromagnetic wave. That is, E is equal to E divided by H. When we have to see about the Maxwell's equation, actually it can be derived from Faraday's law. Del into E is equal to minus of dou B divided by dt equal to minus mu dou H divided by dt. So from this value, so we have to get Hm plus equal to Em plus divided by root of mu divided by E. So normally the above equation is an analogous to Ohm's law. I is equal to V by Z, where I and V are analogous to H and E. So thus the radical term is nothing but that the impedance with unit of ohms. Such impedance is expressed in terms of mu and epsilon, which are the properties of the medium. Hence the impedance is called as an intrinsic impedance of the medium and is denoted by eta. So in general, you know that eta is equal to, that is Em plus divided by Hm, that must be is equal to root of mu divided by epsilon, its unit is in ohms. But for the free space, mu is equal to mu 0, that must be is equal to 4 pi into 10 to the power minus r. Similarly, epsilon is equal to epsilon 0, that is equal to 8.854 into 10 to the power minus 4. Hence, for a free space, the intrinsic impedance is denoted by rho naught and is given by rho naught is equal to root of 4 pi into 10 to the power minus 7 divided by 8.854 into 10 to the power minus 12. So that must be is equal to 377 ohms. Next, we have to see about the propagation constant. The propagation constant, often denoted as gamma, is another fundamental concept in the field of electromagnetism, specifically in the context of wave propagation and transmission lines. The propagation constant is a complex number and consists of two parts. One is phase constant and another one is attenuation constant. Phase constant, its notation is beta. It represents the phase shift that the wave experiences per unit distance along the propagation direction. Beta is equal to 2 pi divided by alpha, gamma. Attenuation constant, that is alpha, it represents the exponential degrees in the amplitude of the wave and it propagates through the medium. That is alpha is equal to m per unit by distance. Hence, in general, the propagation constant can be expressed in